software-defined radios, and what these radios allow us to do, instead of using hardware components, we're able to use configurations within the software to basically reconfigure the antenna. So on this side, this is probably the more important side to look at. We have the receiving radio here, we have a voltage amplification, and we have a microcontroller that's essentially and Usher can kind of explain to you how
configurable antenna. We have an x-axis and a y-axis between which our system switches. It does cross polarization, so it has an x polarization and a y polarization between which it switches. It uses fiber optic cables and photodiodes and photoresistors. Light is transmitted from here based on the control information that the microcontroller has. Based on this, it's going to create conductive paths for either the x-axis to turn on or the y-axis to turn on, and that changes the polarization of the antenna. We have a 2.4 gigahertz signal amplifier that, in a situation where we're in a deep fade situation where we can't get any signal, what it does is it amplifies whatever signal it receives, including the noise. And that noise can be filtered out, and we have the signal itself. One of the best applications for this is band switching, where we can actually switch bands from the different 2.4 gigahertz, 2.5 gigahertz. We can switch frequency bands, and we can change the bandwidth of our signal. We can actually real-time change it for bandwidth-intensive applications using this system.
So, Antonio, I kind of want to explain the rest of what everything else is.
I guess the important thing is the control loop. We have receiving antenna, the radio, and then all the data goes into the computer. The computer analyzes the bit error rate, receives the data, and it makes decisions. And it sends those decisions out here to the microcontroller. And they have kind of a lag of communication. So, since the microcontroller turns those commands into actions, that's where it on these LED and you can boost the signal of the receiver.
And you can see here when we're reconfiguring the antenna, we've coordinated the LED to kind of show you using A, we're highlighting the Y configuration basically of that, and this is the data quality or the bit error rate that we're getting. So hopefully if I can, that's not going to change anything. Right now we have the gain pretty high, so we're receiving high data, but if I turn the gain down, I want to turn the gain down some. If I turn the gain down to say 20, so notice how I was able to just adjust the antenna configurations based simply in software. I didn't have to change any of the hardware. And now we're losing a lot more current data quality simply by turning the gain down on the receiving antenna.
So it's actually switching between the X configuration, Y configuration. It tests the data quality for each configuration, and it chooses the best setting. And based on that, it'll also amplify the signal, and you can see that over there.
So, and I guess kind of the last representation here, we have this is our live streaming data file. I know it's a little more difficult to see right now, but we're just streaming the alphabet first in capital letters and then in lowercase. And when this, well, I don't know if we're able to make the packet size any larger, but you can actually see when we have very, yeah, we can. Do you want to pause that and stop it?
I'm surprised at how well this thing can work on Zoom. I can read the letters.
No, it's alright. Can you change the packet size? Okay. Let's see if I can stop. Okay, so see here, if I pause it, we've received a whole bunch. Right now, see, we're not receiving any characters. And so basically we can still receive information, but that information is not going to have any integrity whatsoever in the original file. And so if we go back and we
hold on, leave the game as it is.
yeah. Come on, just sort of.
So are you guys transmitting at 3 different frequencies? Is that what you're doing?
No, we're just transmitting in one frequency at this point.
The 3 signals that you're...
There's 3 settings, are just the different polarization. So it has an X polarization and a Y polarization.
But the signal being transmitted...
So
Sorry, the 3 streams of data.
It doesn't change. What we're changing is the shape of the receiving antenna, and we're boosting the signal coming in. But the signal being transmitted is the same.
Just so that you account for the fading or something.
Yeah,
Right.
yeah.
Right, so here we changed the gain a little bit higher, and now we have, you know,
So all your decisions are going to be based on BER, right?
Yeah.
that's the metric as of right now. Currently,
Yeah, because, I mean, ultimately it's going to be a problem because you don't know what the actual data is. So how do you calculate the BER?
so you calculate the BER based off a checksum, and essentially you calculate the bit error rate because the software that's currently in GNU Radio analyzes based off a checksum of whether the packet you received is correct or not. And so we decided to use this bit error rate metric for a couple of reasons. First of all, if you use a time type of metric, you run a configuration for a certain time. You're not analyzing necessarily the environment it's in, but just the current configuration settings of the system. So we figured that the bit error rate would be better for measurement of the environment.
Yeah, so the problem with that, I mean, the checksum would just tell you if the frame is in error.
Okay.
It's not going to tell you how many bits are going to be there.
It doesn't, so that's true. It doesn't tell you how many bits are in error. But in our case, we're only interested really in the packet, in the packet. So I see what you're saying. It's not necessarily the bit error rate, but a packet error rate.
Packet.
So
Yeah, that makes sense because I thought because bit error rate you won't
not
have any way of
measuring
telling
individual bits. Right.
So you were saying it would change depending on the packet that the time to transmit, right? So how much variation?
What do you mean?
Like the bit error rate, what range is it trying to?
So you don't necessarily go for a certain range. What this system does is it stands as a platform, right? And so if you say incorporate this, take your iPhone or something like this. You walk into a room and you try, and connect to say Wi-Fi offers the best possible transmission quality to your iPhone. Your iPhone then runs the system and starts to consider that, hey, you set some user-defined threshold perhaps, and you say, okay, it crossed this threshold, let me search for 3G. Perhaps 3G has a better wireless transmission. And so really what this does is it learns about the environment that it's in. And so there isn't necessarily like a range of packet error rate that you aim for. It's more you learn about the environment and then those rates are established. Does that make sense?